ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good morning, my dear students. We studied 3 sets so far in the chapter. We'll try few questions on finding set 1, inverse trigonometric function, chapter 2, inverse trigonometric functions. Trigonometric functions. Yes. Before we continue with the next properties, we already studied 3 properties and finding principal value. Let us start solving problems, type 1 questions based on principal value. I told you that principal value, finding principal value of a inverse trigonometric function. We'll see few more questions. Try this one. Evaluate. Type 1 questions. Evaluate. Give you a set of questions based on principal value. Cos inverse 1 by 2. Cos inverse 1 by 2 plus 2 sin inverse 1 by 2. Second question. Tan inverse of cos into bracket 2 sin inverse 1 by 2. Third one. Tan inverse 1 minus sec inverse minus 2 plus cosec inverse 2 by 3. Cosec inverse 2 by root 3. I have to find out evaluate them. Fourth question. Cos inverse 1 by 2 minus 2 sin inverse minus 1 by 2. Fifth one. Sin inverse minus 1 by 2. Sin inverse minus 1 by 2 plus 2 cos inverse minus root 3 by 2. Using identities, questions on type 1, finding using principal values to solve the problem. That is property number 0, type 1 problems. See the problem first. You know that you are given with cos inverse 1 by 2, cos inverse 1 by 2 plus you are given with 2 sin inverse 1 by 2. Can I write it as sin inverse 1 by 2 plus sin inverse 1 by 2? Can I write it like this? See, now you know that what is cos inverse x plus sin inverse x is. Cos inverse x plus sin inverse x is equal to pi by 2. Do you agree with me? Is it not pi by 2? Plus the principal value of sin inverse 1 by 2. For what angle of sin you get 1 by 2? Must know the principal value is a 30 degree. 30 degree. This is an identity. Which identity? That is cos inverse x plus sin inverse x is equal to pi by 2. I am using this identity already there. We proved it in the previous classes. Sin inverse 1 by 2. The principal value of sin inverse 1 by 2 is pi by 3 or 6. Sin 30. Sin 30 is 1 by 2. The value is pi by 6. Take LCM. LCM 2 6. 2 1s are 2 3s are. LCM will be 3 method. 6. You get 2 3s are 6 1s are. 3 pi plus pi. 3 pi plus pi becomes what? 4 pi by 6. You can simplify further. 2 2s are 2 3s are. You are getting the answer 2 pi by 3. Let us start solving problems. Improve your calculation skills, writing the principal values. I hope you understood this. Note this problem. Next, second question. Second question. Let me rub this. Second question. First question is solved. Okay. Second question. Go on putting the principal values. Tan inverse of. Using principal values, you have to simplify. Cos 2 sin inverse 1 by 2. Now observe, removing the brackets by putting the principal values. Very simple. Tan inverse cos. These may appear for 1 or 2 marks. Cos of 2. What is the value of sin inverse 1 by 2? Sin inverse 1 by 2. For what angle of the sine you get 1 by 2? It is 30 degree. Sine 30 degree. For what angle of sine you get 1 by 2? 30 degree. 30 degree can be written as pi by 6. Pi by 6. Make a radian measure perfect. And 2 1s are, 2 3s are. Now it becomes what? Now it becomes what? Cos pi by 3. You are left with cos pi by 3. Pi by 3 means 60 degree. 60 degree is pi by 3. What is cos 60 degree? Is 1 by 2. Cos pi by 3 is cos 60 degree. The answer is tan inverse 1 by 2. Right? No standard angle for 1 by 2. Right? We have tan inverse 1 by 2. You can put it as it is. The value is tan inverse 1 by 2. Simplified form of it. No standard angle for tan inverse 1 by 2. Therefore, answer will be tan inverse 1 by 2 only. Note down the problem. It's tan inverse 1 by 2. No standard angle for you. For tan inverse 1 by 2, you can put it as it is. The simplified form of this is tan inverse 1 by 2. Okay. Take next. Before I continue the next property, you solve this one. Take the third one. Tan inverse 1. They are very easy. 1 mark questions. Tan inverse 1 minus sec inverse minus 2 plus cosec inverse 2 by root 3. Now, for what angle of the tan you get 1 is pi by 4, because pi by 4 means 45 degree. 45 degree tan 45 degree is 1. Therefore, the principal value is pi by 4. 45 degree pi by 4 minus. You know that what is sec inverse minus x is equal to? Sec inverse minus x is equal to pi minus sec inverse x. Remember, pi minus sec inverse x, you can write it as pi minus sec inverse 2. Right? Later you can put the values plus cosec inverse 2 by root 3. For what angle of the cosec you get 2 by 3 is 60 degree. 60 degree can be written as pi by 3. Study the problem. Pi by 4 minus into bracket pi minus. For what angle of the sec you get 2 is 60 degree. 60 degree means pi by 3. Okay. Plus pi by 3. Simplify and find the principal value. You can write it as pi by 4. Remove the bracket, minus pi. Minus into minus is plus pi by 3 plus pi by 3. Right? You can take a pi common in all of them and simplify it. 1 by 4 minus 1 plus 1 by 3 plus 1 by 3. Take a pi common. Simply you can take the LCM. 4, 3, 3. You will get 4, 3, 3. What is the LCM of 4, 3, 3? 3. 1 za, then you get 4. You will get LCM is 12. You can write the LCM as 12. What do you get here? 4, 3 za 12. 1 12 za, 3 4 za, 3 4 za. You can simplify this. You can write 3 minus 12 plus 4 plus 4. Are you getting me? That is, you get here pi into bracket. 4 plus 4 is 8. 8 plus 3 is 11. 11 minus 12 is minus 1 by 12. You will get minus pi by 12. Is the simplified form of it. Observe. If you have got any doubts, you can clarify. Anybody is there in live stream? Okay. Minus pi by 12. Observe tan inverse 1. I will repeat. Tan inverse 1 value is pi by 4 minus sec inverse of minus x. What is sec inverse of minus x is? Sec inverse of minus x, cos inverse of minus x is pi minus sec inverse x. In the second quadrant, sec inverse will be negative. We proved it. The answer is minus pi by 12. Answer is minus pi by 12. Note down the problem. Check. Tan inverse 1 minus sec inverse 2. Pi minus sec inverse 2. Second one. Any doubts in this? The answer is minus pi by 12. Take the next one. Fourth one. Sin inverse minus 1 by 2. Fifth one. Try this. Take 1 or 2 minutes. Sin inverse minus 1 by 2 plus 2 cos inverse minus root 3 by 2. Try to solve the problem. Problem is sin inverse minus 1 by 2 plus 2 cos inverse minus root 3 by 2. What is sin inverse minus x is? Sin inverse minus x is, you know that sin inverse minus x is equal to minus sin inverse x. Remember, already we proved it. Cos inverse minus x is equal to pi minus cos inverse x. Check the identities we proved, you can use them also. Sin inverse minus x becomes minus sin inverse 1 by 2 plus 2 into bracket. What is pi minus cos inverse x is? Pi minus cos inverse x is pi minus cos inverse root 3 by 2. Just substitute the values. For what angle of the sine you get 1 by 3, 1 by 2? You will get it for pi by 30 degree. 30 degree can be written as pi by 6 plus 2 into bracket pi minus. For what angle of the cos you get root 3 by 2? Is 30 degree. 30 degree is pi by, yes, pi by 6. 30 degree cos pi by 6. You can write down minus pi by 6. Remove the bracket. Plus 2 into pi is 2 pi. Plus into minus is minus. You will get 2 pi by 6. 2 ones are, 2 threes are. Minus pi by 3. You can write now 2 pi minus pi by 6 minus pi by 3. What do you get here? By taking LCM, you can simplify this. You can take LCM here. LCM becomes 6. 1 6 are, 6 ones are, 3 twos are. Simplify. 12 pi minus pi minus 2 pi. What do you get here? 12 pi minus 2 pi becomes 12 pi minus 2 pi minus 3 pi divided by 6. 12 pi minus 3 pi becomes 9 pi by 6. You can cancel it. 3 threes are, 3 twos are. The answer will be 3 pi by 2. 3 pi by 2. Three pi by 2. I hope you understood all the set of problems. This is a type 1 problems based on principal values. Right? First set of questions. Study the problem. If you have got any doubts, you can clarify. Let us move on to the next type now. Next problem based on identities. Problem from the textbook on the same type 1. Sixth one, you can take in the type 1 only from the textbook. Tan inverse 1 NCRT. Tan inverse 1 plus cos inverse minus 1 by 2 NCRT textbook plus sin inverse minus 1 by 2. Then seventh one. Cos inverse 1 by 2 plus 2 sin inverse 1 by 2. Simple questions. And one MCQ based on this. tan inverse root 3 minus sec inverse minus 2 is equal to, the options given are A pi, B minus pi by 3, C pi by 3, D 2 pi by 3. Solve the problems given in NCERT text based on these properties we studied so far. Finding principal values from the NCERT text, remaining are easy. Now you can put the value, sixth one, directly. Tan inverse 1, let me take the problem. Tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. You can use the identity now. For this, you can directly write the value as pi by 4. But you know that cos inverse minus x is cos inverse minus x, recall, is equal to pi minus cos inverse x, because cos inverse x is negative in the second quadrant. Sin inverse minus x is minus sin inverse x. Let me write it as pi minus cos inverse 1 by 2 plus, what is sin inverse minus 1 by 2 is, what is sin inverse minus x? We proved it as minus sin inverse x. Check the property list. Minus sin inverse 1 by 2. Let us put the value. Pi by 4 plus pi. For what angle of the cos you get 1 by 2? 60 degree, which is pi by 3, plus into minus is minus. Sin inverse 1 by 2. For what angle of the sin you get 1 by 2? 30 degree, which is pi by 6. Right? You can write now. Again take common. Pi is common. Left with 1 by 4 plus 1 by 1 minus 1 by 3 minus 1 by 6. You can take LCM and simplify. When 4, 3, 6 are LCM. 4, 3, 6. You can divide tree method, 2 2s are 3, 2 3s are. Now you can divide by 3, 2, 1, 1, 2, 1, 1. That is the way of getting LCM. 3 2s are 6, 6 2s are 12. 12. You can take 4 3s are 12, 1 12s are, 3 4s are, 6 2s are. You can write 3 1s are 3 plus 12 1s are 12 minus 4 1s are 4, right? Minus 2. You can write the values, pi into bracket. 12 plus 3 is 15. 15 minus 6 is 9. 12 plus 3 is 15. 15 minus 6 is 9 by 12. You can simplify. 3 3s are, 3 4s are. You will get 3 pi by 4 as the principal value of this particular problem. Just now I think we solved cos inverse 1 by 2 plus sin inverse 1 by 2. NCERT textbook questions. And choose the correct options among them. See, let us check it. Tan inverse root 3 minus sec inverse minus 2 can be written as pi minus sec inverse 2. Tan inverse root 3 value you can put, for what angle of the tan you get root 3, 60, means pi by 3 minus into bracket pi minus sec inverse 2. For what angle of the sec you get 2 is a 60 degree. 60 degree can be written as pi by 3. You can simplify it as a pi by 3 minus pi, minus into minus is plus pi by 3. This pi by 3 becomes 2 pi by 3. 2 pi by 3 minus pi. You can take LCM here, 3. 3 1s are, 1 3s are. You will get 2 pi minus 3 pi. Becomes what? 2 pi minus 3 pi becomes minus pi by 3. The correct answer is B in it. That is NCERT questions. Next type of right? I hope you understood the problems based on principal value of the functions. Clear? Now you can continue with the type 2 questions. Type 2 questions will appear. You must be perfect in writing principal values, whatever properties we proved. Based on that, we are going to solve the problems. See, using trigonometric identities, evaluation using trigonometric identities. I will give a set of questions. Observe here. Using trigonometric identities. You studied in the first PU, half angle formula, T identities, trigonometric identities. You have to simplify. I given you list of identities. You can use them directly. That is, you are given with tan inverse. Evaluate root of 1 minus cos x divided by 1 plus cos x. Right? The condition is minus pi is less than x, x is less than pi. X is less than pi. Try this problem. Let us try this problem. How to evaluate it? You know that half angle formula. I have given you root of 1 minus cos x upon 1 plus cos x. We have simplified it and you have written it in the TSR time saving result. 1 minus cos x can be written as 2 sin square x by 2. Sin square x by 2 upon 1 plus cos x is 2 cos square x by 2. You can watch my previous videos. Already we have done it. Sin square x by 2 upon cos square x by 2 is root of tan square x by 2. Root of tan square x by 2 is tan x by 2. Observe here. You will get the answer tan inverse. Square root will be modulus either plus or minus tan modulus of tan x by 2. Right? And it can have two answers. Right? When minus pi is less than or equal to x, x is less than or equal to pi. Right? For x by 2, if you divide throughout by 2, you will get what? Minus pi by 2 is less than or equal to x by 2 is less than or equal to pi by 2. It can have two values. Are you getting me? This tan will be, observe, minus pi by 2 to plus pi by 2. It can have two values. 0 to pi by 2, it will be positive. 0 to pi by 2, it will be positive. And minus pi by 2 to 0, it will be negative. Therefore, it can have two values. That is tan inverse of plus tan x by 2. Observe, where it is positive, when 0 is less than or equal to x by 2, x by 2 is less than pi by 2, means 0 to pi less than 0 is less than or equal to x by 2, x less than or equal to pi by 2. 0 to pi by 2, when it is in the first quadrant, it will have positive value. Therefore, you will get the answer x by 2 plus x by 2. There are two values possible for this. Second one is tan inverse of minus tan x by 2, where it will have tan minus x by 2. Where the tan can have negative values. Minus pi by 2 is less than x by 2 is less than or equal to 0. When it lies between minus pi by 2 0, it will have the value tan value will be minus. That is, you get minus tan x by 2. Therefore, you get tan inverse of minus tan x by 2 can be written as tan minus x by 2. Minus pi by 2 to 0 comes in the principal value. Therefore, tan inverse of tan x is equal to x. You will get the answer x by 2. Study carefully. Whenever you will take square root, you will have one positive value, one negative value. Where it will be positive, 0 to pi by 2. When you given, this is the given condition. When you divide both sides by 2, you will get from 0 to pi by 2, it will be positive, and minus pi by 2 to 0, it will be negative. Therefore, minus tan x by 2. Because in the fourth quadrant, ASTC rule, tan value cos and sec are positive, but tan is negative, you will get minus tan x by 2. Therefore, minus tan x is equal to tan minus x. Therefore, tan inverse of tan minus x by 2 will be minus x by 2. I hope you understood the problem. Okay. Let us continue with the next problem. Using a trigonometric identities. Nobody in the live stream today. No problem. You watch at your free time. Then you can ask the doubt questions. Continue. Second problem on it. Try this one. You have tan inverse cos x, tan inverse. Simplify this using trigonometric identities. Tan inverse cos x upon 1 plus sin x, cos x upon 1 plus sin x minus pi by 2 is less than x, x is less than pi by 2, means it lies between minus pi by 2 to plus pi by 2. Try to find out the answer. Yes. You have to use half angle formula. Half angle formula, I can write it as tan inverse may appear for 2 marks or 3 marks. Evaluate it. Look at the restriction minus pi by 2 to plus pi by 2. You can write this cos x as half angle formula. What is cos 2x is cos square x minus sin square x. Cos 2x formula. Cos 2x is equal to cos square x minus sin square x. When you solve it, cos x can be written as cos square x by 2 minus sin square x by 2. You remember, what is 1 plus sin x? 1 can be written as cos square x by 2 plus sin square x by 2. Observe carefully. Plus, what is sin x is? Sin 2x is 2 sin x into cos x. Sin x can be written as 2 sin x by 2 into cos x by 2. Observe, is it not in the form of a square plus b square plus 2ab? Then it becomes what? A square plus b square plus 2ab can be written as a plus b whole square. There you get cos x by 2 plus sin x by 2 the whole square. Similarly, cos x is equal to cos square x by 2 minus sin square x by 2. Let me write in the numerator. Is it not in the form of a square minus b square? Using that, you can write it as cos x by 2, a square minus b square identity, plus sin x by 2 into a plus b sin x by 2. Then into, I will write here cos x by 2 minus sin x by 2. A plus b into a minus b. We are using these two identities. Let me write them directly like this. Cos x, henceforth you remember, can be written as cos x by 2 plus sin x by 2. I will write here cos x can be written as cos x by 2 plus sin x by 2 the whole square. Do you agree with me? Divided by 1 plus sin x. Henceforth you remember 1 plus sin x can be written as cos square x by 2, that is cos x by 2 plus sin x by 2 into cos x by 2. Just now I discussed it. You can write it as 1 plus sin x. 1 plus sin x, sorry, I think I have written it. Numerator is cos square x by 2 plus cos x by 2 plus sin x by 2. Cos x by 2 minus sin x by 2. And 1 plus sin x can be written as cos x by 2 plus sin x by 2 the whole square. You can cancel cos x by 2 plus sin x by 2. 1 cos x by 2 plus sin x by 2. 1 cos x by 2 plus sin x by 2 gets cancelled. Now you are left with that is cos x by 2. You can remember them as TSR, time saving results, upon cos x by 2 plus sin x by 2. This can also become an identity. You can remember these identities so that you can directly substitute. Observe here, I will show separately. Cos x by 2, I will simplify it, minus sin x by 2 divided by cos x by 2 plus sin x by 2. Now we'll do one thing. You can remember it as a time saving result for competitive exams. Divide numerator and denominator by cos x by 2. What I am going to do, you will understand shortly. That is cos x by 2 upon cos x by 2 becomes 1. Sin x by 2 upon cos x by 2 becomes tan x by 2 divided by cos x by 2 upon cos x by 2 becomes 1 plus sin x by 2 upon cos x by 2 can be written as tan x by 2. Let me write 1. Wherever there is 1, can I write a tan pi by 4, 45 degree? Tan pi by 4 minus tan x by 2 divided by 1 plus. Can I write tan x by 2 as tan x by 2 into 1? We will get tan x by 2 into 1 can be written as tan pi by 4. Observe this. Is it matching with any of the multiple angles you studied? Deepti is present. Any doubts, Deepti? Check. We will get here tan A minus tan B upon 1 plus tan A into tan B. Tan A minus tan B upon 1 plus tan A into tan B is nothing but what? Tan pi by 4 minus x by 2. I hope you got it. This is the time saving result. You can use it for directly. You can remember it as a time saving result as a tan pi by 4 minus x by 2 if the question appears in competitive exams. Note it in your TSR book, time saving results book. They are very useful. That is tan inverse. You can write it directly as a tan pi by 4 minus x by 2. Now it is in the form of tan inverse of tan x is equal to, because it is in the restriction, x lies between the restriction. See, the restriction Now, Yipti, listen to me. Hello? Now check whether the voice is clear or not now. Yes. Can you hear me now? Okay. Okay. Try this one. Use the identities. Time saving results. We will collect the time saving results first. And you can solve them in the exam on the right side. See, you must know how to express cos x. Already we studied. Cos x can be written as cos x by 2 plus sin x by 2. Clearer? And cos x by 2 into cos x by 2 minus sin x by 2. This time saving result is already ready with you. 1 minus sin x, use common sense. 1 minus sin x, I think I can write it as cos square cos x by 2 minus sin x by 2 whole square. Or even if it is 1 minus sin 2x, you can note down this as fourth result. This is fifth one. 1 minus sin 2x can be written as cos x minus sin x the whole square. This is half angle formula. This is multiple angle formula. Because one can be written as cos square x by 2 plus sin square x by 2 minus sin 2x can be written as sin 2x can be written as 2 sin x into cos x. It will be the expansion. Using those identities, I can directly write the numerator as tan inverse minus 3 pi by 2 pi by 2. Where the minus 3 pi by 2 comes? See, this is pi by 2. This is this is 0. This is pi by 2. Right? This is pi. This is 3 pi by 2. Minus 3 pi by 2 to pi by 2 means fourth quadrant and first quadrant. You have to identify where x lies. Minus 3 pi by 2 pi by 2. This is minus 90 to this. Cos x can be written as, you can use cos x by 2 plus sin x by 2. Similar type of the problem given in your textbook, solved in your textbook, into cos x by 2 minus sin x by 2 divided by. This time you have 1 minus sin x can be written as cos x by 2 minus sin x by 2 the whole square. Observe. This time cos x by 2 minus sin x by 2. One of the cos x by 2 minus sin x by 2 cancels. This time you get tan inverse cos x by 2 plus sin x by 2 divided by, you are left with cos x by 2 minus sin x by 2. Now the time saving result just now we collected. You can directly use them in the competitive exams, but you have to write step by step in the board exam. We proved that cos x by 2 in the previous case minus sin x by 2 upon 1, that is cos x by 2 plus sin x by 2. Just now I have shown you the shortcut as a tan pi by 4, right, minus x by 2. Just the sign is different here. you can use your common sense. Cos x by 2, you have plus sin x by 2 divided by cos x by 2 plus sin x by 2. Is it not in the form of 1 minus tan? You can use simply tan pi by 4 plus x by 2. In the numerator there is plus, denominator there is minus in the given problem. Here, in the previous case, numerator was minus, denominator was plus. When the numerator is minus, denominator is plus, it is tan pi by 4 minus x by 2. When the numerator is plus, denominator minus, it is tan pi by 4 plus x by 2. You can directly use the identity and write the identity on the right side, and you will get tan inverse tan. Can I write it as pi by 4 plus x by 2? Tan inverse of tan pi by 4 plus x by 2 can be written as pi by 4 plus x by 2. In a written exam, you have to show the identities clearly. In competitive exams, you can use a TSR directly and take the correct answer within a minute. I hope you got it. Very good. It is clear now. Third type, I hope you understood this type, right? Third type of the questions. Simplification using substitution. I will take some problems. You have to make the proper substitutions. Evaluation of inverse trigonometry using substitution. Third type of questions using substitution. Evaluation of inverse trigonometric functions using substitution. I will take a problem. From your textbook only. Tan inverse NCRT first. Then I will give more problems. First one from your textbook. Tan inverse root of 1 plus x square minus 1 upon x. X is not equal to 0. You have to simplify it to the standard form, right? You have to make the proper substitutions. Root of 1 plus x square minus 1 upon x. What substitution you can do to simplify this? You have to put the proper substitution at the place of x to simplify this and get it. Now, whenever you get a root of 1 plus x square, the nearest identity is root of 1 plus tan square theta. Now, in this case, you remember the proper substitution will be whenever there is 1 plus x square or root of. Sometimes you may get general form root of a square plus 1 plus x square, a square plus a square x square, or a square into bracket 1 plus x square if you have. That is 1 plus x square. Best substitution is x is equal to tan theta. Because once you get x is equal to tan theta, root of 1 plus tan square theta becomes what? Root of 1 plus tan square theta becomes what is root of 1 plus tan square theta? Yes, is sec theta. So that you can solve easily. Now let me put x is equal to tan theta. so that theta becomes equal to tan inverse x. At the end, you have to express it in the form of tan inverse x. Let us try this. Tan inverse of root of 1 plus tan square theta minus 1, okay, divided by x is what? Tan theta. Let us put this substitution and try to simplify. This is called as method of substitution. Now under root should be eliminated. What is the root of 1 plus tan square theta is? You are left with tan inverse. Root of 1 plus tan square theta is sec theta minus 1 upon tan theta. Now the problem is you have to simplify this using trigonometric identities. How can I write sec theta as? Sec theta can be written as 1 upon cos theta minus 1 upon 1. 1 can be written as 1 upon 1. Tan theta can be written as sin theta upon cos theta. Now continue. Try to simplify this. Simplify, take some 30 seconds, 1 minute. Now you can write it as tan inverse. Take LCM. Becomes what? Cos theta into 1, 1 minus cos theta. You will get here 1 minus cos theta divided by cos theta in the numerator, in the whole denominator, sin theta upon cos theta. Cos theta cancels. Now you are left with very interesting result. Tan inverse 1 minus cos theta upon sin theta. We will prepare a time saving result for this. TSR. In the rough you can find it out and note down the CSR. Go on giving numbers. They will help you. Keep it in your diary. 1 minus cos theta divided by sin theta. We'll prepare a shortcut to this. You can even do it in the rough in the exam and show the examiner. And remember this as a standard identity. 1 minus cos 2 theta is 1 minus cos 2 theta is equal to 2 sin square theta by 2. 2 sin square half angle formula. Check in your list. 2 sin square theta by 2. Sin theta can be written as 2 sin theta by 2 into cos theta by 2. 2 cancels. One of the sin theta by 2. Sin theta by 2 cancels. You are left with what? Sin theta by 2 upon cos theta by 2 is equal to tan theta by 2. Look at the question. Remember this as identity 1 minus cos theta as a TSR, time saving result. Note it down. Whenever you come across 1 minus cos theta upon sin theta directly in the competitive exam, you can put it as tan theta by 2. That is tan inverse. You can write down tan theta by 2. Are you getting me? What is tan inverse of tan theta? Is a theta by 2. But your answer should not be written in theta by 2. What is your assumption is? Put x is equal to tan theta you have taken. The restrictions minus pi by 2 to plus pi by 2 is there. Therefore, inverse trigonometric function exists. Therefore, theta becomes what? Tan inverse x. Now you can write it as 1 by 2 into theta. What is theta in terms of x? You have to write. Many students leave it in the theta only after making substitution. 1 by 2, you can write it as tan inverse x. Tan inverse x. The answer should be 1 by 2 tan inverse x. Note on the solution. Yes. Hardik. नहीं क्या होता क्लास इतने सुबह मीन्स मेरा स्कूल रहता है. There are many students who have to go to the college at 8 o'clock. Right? They have to leave the college at 8 o'clock. Many integrated colleges students are going. इसलिए मैं सुबह देता हूँ 6:45 to 7:45. That's a thing. because there are some colleges which leave the students evening at 7:30. Therefore they will be tired. In the morning students will be fresh. Therefore I am taking second Puc classes generally in the morning. Early morning is best. You just have the practice of waking up in the early morning. Your mind capacity to calculate maths will be improved. Don't wake up late. Sleep early, wake up early. Bega malagu, bega edu. Okay, that is a good policy. Whole day you will be fresh. The final answer will be tan inverse. That is 1/2. Tan inverse. You can directly write it as, you can show the calculations on the side. You can write it as tan theta by 2. That is equal to, you are written theta by 2, tan inverse of tan theta by 2, theta by 2, 1/2 tan inverse x. Hardik, thank you, thank you. Early morning wake up, because this is my experience as a science student. Early morning your mind will be very fresh, particularly between 4 to 6 early morning. If you go to bed by 11 o'clock or 10 o'clock, you wake up, you stop the work at 10 o'clock, start the work at 4 o'clock. You see the difference. Your mind, because that is called as Brahmi Muhurta in Indian philosophy, and all saints will suggest this. Many saints who did great works, they used to wake up at 3 o'clock early morning. That time is very best time. Nowadays you people in this generation is not taking care of early morning wake up. Our teachers we used to wake up at 4 o'clock. Till now also I wake up in the early morning, do some exercise, yoga. See, your mind will become sharp, very sharp. Your judgment taking capacity, whole day you will be fresh. You go to bed early, you just experiment it and tell me. I have experimented it, but it is very difficult to wake up in the early morning for 3 weeks. For 3 weeks you feel very difficult to wake up, but once 21 days, anything if it is practiced, it will be practiced. So I have got 33, more than 33 years. I am waking up in the early morning at 4 o'clock and do yoga, and whole day I will be fresh. I will take 10 hours per day. No problem. Have this habit. 1/2 tan inverse x. Indian pure methods I am using here. So what our saints told, I am following. So these are the things. Okay, substitution. Okay, we'll stop here. So tomorrow we'll continue with the first chapter, solutions. Tomorrow will be chemistry, and by the time I will send you some assignments in the WhatsApp group. Join the WhatsApp group. I'll give you assignments. You can solve them. And you are getting late to the college, many of you. Bye bye. See you tomorrow morning at 6:45.